Hey, it's Mr. E here, and our aim for this video is what is the cyclic nature of the powers of I? So here's a warm-up for you. What is the digit in the ones place of 33 to the 408? So to guide you a little bit here, I listed out all the digits for 33 to the 0, all the way up to 33 to the 6th. And just to give you an idea, in case you forgot what the ones place means, you know, the ones place is the first digit to the left of the decimal. So in 33 to the 6th, the digit in the ones place is 9. I want you to tell me what the digit in the ones place is for 33 to the 408th power. Can you figure it out? Okay, so how do we figure it out? Well, I hope that you would have noticed that there is a pattern here. Look at the digits in the ones places from 33 to the 0 onward. It goes 1, 3, 9, 7. 1, 3, 9. Guess what the next one's going to be? You guessed it, 7. We have a pattern here for the digits in the ones places. They go 1, 3, 9, 7. 1, 3, 9, 7. We could even make a song out of it. This here is a cycle. So the cycle repeats for every 4 integers of the exponent. So how do we use that to our advantage? How do we use that? Let me do it for a smaller number to show you. Let's do it for 33 to the 10th power. I'm going to take the 10 and I'm going to divide it by 4. Why 4? The reason I'm dividing by 4 is because the cycle repeats for every 4 integers of the exponent. And I'm doing the old school division here because I want to see what the remainder is. So 4 times 2 is 8. And that leaves me with a remainder of 2. Now, why did I want to see what the remainder was? The remainder was 2, so I can use that remainder as a guide to see what the digits in the ones place is going to be. So remainder is 2, so I go to 33 to the 2nd power. And I know the digit in the ones place for 33 to the 10th is going to be 9. And here, I'll help you verify it. I'll show it to you. Look, this is 0, 1, so 0, 1, 2, 3. We know the pattern is going to repeat. So this is 33 to the 4th as well. 4, 5, 6, 7, 8, 9, 10. And, you know, I'm just looking at the ones digit. I know it's going to be 9. So let's do it for 33 to the 408. So take 408 divided by 10. Excuse me, not 10, 4. Take that back, correction, divided by 4. You're dividing by 4 because the pattern repeats for every 4 integers of the exponent. So when you divide that by 4, you are going to get 102. 4 times 102 is exactly 408. The remainder is 0. There is no remainder. So I go to 33 to the 0, and I know the digit in the ones place is going to be 1. So the answer, what is the digit in the ones place of 33 to the 408? Whoops, spelled that wrong. It is 1. It is 1. That's the digit in the ones place. Alright, so basically what you do is you just divide the exponent by 4, see what the remainder is, and then use the remainder as a guide to find what the digit in the ones place is going to be. Why do we divide by 4? Because the pattern repeats for every 4 integers of the exponent. All right, let's talk about imaginary numbers. The imaginary unit is defined as the square root of -1. So I is equal to the square root of -1. It is said that the term imaginary was coined by René Descartes in the 17th century and was meant to be a derogatory reference, since obviously such numbers did not exist. Today we find imaginary unit being used in mathematics. In science, electrical engineers use the imaginary unit, which they represent as J, in the study of electricity. Here are some examples of imaginary numbers. Remember, I is equal to the square root of -1. So 3i is just another way of saying 3 times the square root of -1. Same thing with -7i, same thing with 5i to the square root of 2. Okay, what is a complex number? A complex number is any number that can be written in the standard form a plus bi, where a and b are real numbers, and I is the imaginary unit. So for 7 plus 2i, a is 7 and 2 is b. And a and b could be any real number for it to be complex. Okay, the cyclic nature of the powers of I. Now you see why we had to do now that we have it. Is there a pattern? Is there a cycle for the powers of I? Well, let's see. As you know, I is the square root of -1, so keep that in mind. I to the 0 is equal to 1. Anything raised to the 0 is 1. I to the 1 is just I, or the square root of -1, but I'm just going to express it as I. I can express it as the square root of -1 as well, but I just want to express it as I, because that's how I to the 1 is usually expressed. It's expressed as I. Okay, now, what would I squared be? What would I squared be? Well, think about it. I is the square root of -1. So I squared is the square root of -1 multiplied by the square root of -1. So what happens when you square a radical? You lose the radical. So I squared is -1. What about I to the third? What would I to the third be? Well, it's going to be the square root of -1 times the square root of -1, which is -1, times the square root of -1, or times I, and that's going to be -1i, or just -I. So I to the third is -I. What about I to the fourth? I to the fourth is going to be, you could think about it as I to the third times I to the 1. We already know what I to the third is. It's -I, so it's going to be -I times I, which is equal to -I squared. Now, what is I squared? I squared is -1. So -I squared is -1, which is +1. If this is really confusing you, give you two options. You could just replay that part slowly. But what's really important, look, what you really need to know, right, is this, that there is a cycle going on here. Do you see it? It goes 1i, negative 1, negative I, and then it's going to repeat 1i, negative 1, negative I, and then 1 again. So it repeats. The cycle repeats for the powers of I. And it repeats for every 4 integers of the exponent, just like the do now. So let's move on. Example 1. Evaluate I to the 13 times I to the 17. Well, I to the 13 times I to the 17th is I to the 30th, right? You got to add the exponents. Add the exponents. You should know that because we covered multiplying variables with exponents. All right, now what's I to the 30th? Well, we spoke about this. There's a cycle. I to the 0 is 1. I to the 1 is I to the second is negative 1. I to the third is negative I. And then that cycle is going to keep repeating. That's the cycle. So what do you do? Well, since it repeats every 4 integers of the exponent, let's take 30. Let's divide it by 4. 4 times 7 is 28. We get a remainder of 2. And let's use that remainder as a guide. So remainder is 2. So we're going to look at this. Well, it's negative 1. So I to the 30th is equal to negative 1. That's the final answer. All right, look, there is another thing you can do. On the calculator, if you go to mode, go down to where it says real. Real should have been selected. Just move it to the right to a plus bi. Hit enter and then quit. And then just type in I to the 30th. And I think it'll simplify it for you. I to the 30th is negative 1. Example 2. Simplify the expression to a plus bi form. So I just, I put the cycle here. So we could just have it. Okay, basically, look, this is not going to be pretty for some of you because we have to simplify I to the 98. We have to simplify I to the 73, I to the 68, and I to the 41, just like we did in example 1. So that means 4 division problems. I mean, look, that's really not so bad, but you guys like to complain about everything. So I got my dual screen going on here. So I know that, so this one I'm doing to simplify I to the 98. Let me just make space here. So this one I'm doing to simplify I to the 98. This one I'm doing to simplify I to the 73. This one is for I to the 68. And this one is for I to the 41. So you got yourself 4 division problems. We want to know what the remainders are. So let's go with I to the 98. All right, so 4 times 2 is 8. 9 minus 8 is 1. Hopefully you remember how to divide like this. Um, bring down the 8. So we got 4 times 4. That's 16. You get 2 as a remainder. So the remainder here is 2. So that means we're going to use this here as our guide. So I to the 98 is negative 1. Okay. Let me just move this up. I'll leave it there, whatever. So now for 73. For I to the 73. So 4 times 1 is 4. 7 minus 4 is 3. Bring down the 3. 4 times 8. So I'm going to get a remainder of 1 here. Here the remainder is 1. So I'm going to use I to the 1 as my guide. So it's going to be I. Whoops, I want to use black ink for that because I want to confuse you. So that's going to be I. Okay, so just do the other division problems. Take a minute to do that. So as you can see on the screen here to the right, I worked out the division and I got a remainder of 0 for when I did 68 divided by 4. So that means I to the 68, remainder is 0. So this here should be 1. It's supposed to be a 1. And then for I to the 41, the remainder was 1. So this should be I. Excuse me, this should say remainder 1 here. Okay, now let me get rid of the dual screen. You don't really need it anymore. Single page display. So now we're going to substitute. So we know I to the 98 is negative 1, so I substitute negative 1 in here. I to the 73 is I, so I substitute I in there. I to the 68 is 1, so I substitute 1 in there. I to the 41 is I, so substitute I in there. Simplify. Combine the like terms. Here we got 12i. We got negative 10i. That's 2i. And then we got 8. Take away 2, that's 6. Since you wanted an a plus bi form, make sure the 6 goes first. That's your final answer. Okay, really hope this video helps you. Look forward to working with you on this tomorrow. Take care.